Good morning, ladies and gentlemen. About to welcome in room 15, where? So we are going to start with SAT problem today, and we're going to continue going into factoring. Now, has everybody here turned in their take-home test except for Bo? You haven't turned yours in yet?
I lost mine. I can get another one.
I haven't turned it in. You don't get extras in the
Sorry, Mr. G.
I'm done.
Well, what this does, it allows me to get, I'm supposed to get so many test grades in over the, so this really helps us out. And also, to start out, it starts you out with a good test grade, we hope, right? If you don't get a good test grade on this take-home test, then you're in some serious trouble, right?
I'm hoping I'll get 100.
Yeah, so you should get 100 or close to it. That's the idea. Anyway, so we have this SAT problem today, and basically we have one of the maybe the most famous conversion formula out there, which is Celsius, or in this case Fahrenheit to Celsius. How do you do that? And we're going to be working on this formula later on when we talk about inverses of functions, because this is a classic inverse function equation. And so basically you're given these three statements, and then your answer depends on which of these statements is true. So what do you think about this? What did you get for this one? B? Okay, what you have here, it says statement 1, a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. Well, Celsius, if you just boil down here and just look at this right here, this statement is 100% correct, right? Because if you increase Fahrenheit by 1, in fact, that's the definition of slope. Slope is the answer to the question, how much does y change when x is increased by 1? Well, if you increase f by 1, y is going to change by 5/9. So yes, so B and C are not correct answers based on that. Okay, now what about condition 2 here? Is that true? Because that's going to decide your answer to the question, whether A or D. Well, let's go take this thing. We're going to go ahead and solve this for F. So if we take this equation here, if we take the C equals 5/9 quantity F minus 32, and we solve this for F, what do we do to solve for F? How do we solve for F here? Let me rewrite F, make it a little more legible. How do you solve for F here? Guys, come on. We don't need to have you retake Algebra 1. How do you solve for F?
For F, you've got to distribute, right? No.
You're trying to solve for F. What's the first thing to do? Here, I'll show you what happens is, and we're going to go into equation solving later on. I want to show you this. There's a method you could do is called an onion method. And so what you do here is you take what you're trying to solve for, and then you layer it up into, so we're going to go ahead and take care of this. That's the next layer, and the final layer is going to be actually, hang on a second, I got it wrong. This is going to be our next layer here, and then our final layer is going to be this one here. There we go. So to go ahead and solve this, what's the first layer we deal with? The 5/9, right? So what do we do to unpeel this layer here? What do we do to get rid of that 5/9? No, we're trying to undistribute. We're trying to get rid of this.
That's what I just said. Shut up.
So how do we get rid of this 5/9?
Divide.
By
Two.
multiply by
Three.
what do we multiply by? What do we multiply by to cancel out this 5/9?
Divide by itself. 5/9.
5/9.
What do we multiply by to cancel out this 5/9?
0.
1.
No. Okay, what you're looking for, there's something in mathematics called a reciprocal. And reciprocal, the definition is what number, question mark, do you multiply by 5/9 to equal 1?
Itself. Oh,
No. What number times 5/9 equals 1?
5 now?
9/5.
9/5, thank you.
I was gonna say that, but I thought you were.
And so this informs where you're going, because we want to multiply this thing by 9/5. And so if we multiply this by 9/5 here on this side, and also by 9/5 over here, then what happens to this layer? Cancel out. So what we have left is, we'll just rewrite this now. We have this f minus 32, because that's what we have left, equals 9/5 c. All right? So what's the last layer we're peeling off? The minus 32. What do we do to take care of that?
And 32.
Add 32. So if we add 32, we have f equals 9/5 c plus 32. Okay, so that's going to be our conversion to get from Celsius to Fahrenheit. And so we look at this statement here: a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. So this is a true statement. Yes, it is.
Yeah, so it's
What is 9/5? It's 1.8, right? So that is correct. And so we have answer choice D. Okay, I had to, but did you guys work on multiplying by reciprocals? Because it seemed like I had to, it was like pulling teeth to get you there.
That was too long ago to remember.
But it's a long time ago, but that's very elementary, like.
Then why don't they teach you now? I'm just saying.
Yeah, I mean, really, that's the point. It's that elementary. So, but I guess you're in math class to learn. Maybe you learn from this. I don't know. Hopefully, yeah, hopefully. But in fairness, I will say this is a problem 15, which by the statistics will be the more challenging problems in the sets that we're working on. So,
Yeah.
yeah. Okay, what we're going to do is take this, the exercise we're working on yesterday, and we're kind of working on a mixed exercise set right here. And I think it's this one here. And I think we got to number 7, didn't we? On this one? Did we finish 8? We're on 8, we're starting 8, okay. And so what we're doing with these exercises, we're just trying to look through some factoring situations and techniques, kind of point to where we're going to be heading in part. So here we are at number 8. And so what kind of factoring can you, whose paper is this? This one. It's right here.
All right.
Is that yours? All right. So what on number 8? What factoring can we do at number 8? Okay, first step in all these is you look for the greatest common factor. So what can we do for number 8? What do we have in common between this 5x squared and this 10? What is in common between those two?
Common factor is 5.
So 5, right? Thank you. So 5. So 5 times what equals 5x squared?
X squared.
X squared. And what times 5 equals 10?
2.
Equals 2, right? And then, if you had a difference of squares, you could factor this further, but we don't. So we really can't do anything farther, right? So we're going to just have to leave it there, okay? So that's really all we have for that one. All right, let's go on to number 9. When people, so how would you factor number 9? I want to go back in this. See, I want to go look at this earlier ones. Okay, this number 9 is going to be similar to 6, which is similar to 3. Yeah, similar to 6 and 3. So let's go look at that. And how do I know they're similar? What's similar between 9 and 6?
They're both 3. They can be divided by 3.
No, that's not what's important in common. What's important in common between 6 and 9?
Both.
The minus, right?
How are they minus?
The minus is squared, right? Yeah, very good. And same with 3, right? So what are you going to do with number 9? Yeah, I'm just bringing this up to try to get you thinking about how to factor and about techniques for that. So what are you going to do with this one here? What is your square root of 4x squared?
2.
What is your square root of 4x squared?
2x.
It is 2x. Thank you.
No, it's not.
Okay, look at this. I want to show you something. 2x is not equal to 2. Right? Can we agree with that?
Sure.
So 2x is what goes here. So what goes next here?
Plus 3,
So plus 3,
y,
plus 3y,
and minus 3y.
and minus 3y. Okay? All right, see, that's not too hard, is it?
It's not that hard.
It's not hard, but it's just getting used to it, right?
Yeah.
It's confusing. The reason it's confusing is because you don't have enough experience at it yet.
Exactly.
That's what it is. And that's why you're in the perfect class for you today, which is Algebra 2, here in Wildcat Country. Good job.
In the hood.
That's right.
In the hood, right. Uh-huh. That's right, you reminded me of the homies in the hood. So, I want you to look at this one, number 10.
So that's when you're ready.
Mr. G, if you reach this further back, I'm down. That's all I'm saying.
I'm stabbing this exactly. That's not very nice.
I know Bo got guns.
Because I'm down. I gave you the donut.
All right,
At least you won.
what about this one here? You got a quadratic trinomial. So what would you expect to get as your factoring of a quadratic trinomial? Okay, let's go look at other ones that are similar that we've done earlier in this, on this sheet. Let me show it. Let's go back. So that one, number 10, is going to be similar to 7, which is in some way similar to 5, which is similar to 4, which is similar to 1. So what are you going to look for on number 10? What is your answer going to look like?
I don't know.
Okay, now, if it's factorable, your answer is going to look something like this. So you can just, when you see that, a quadratic trinomial like that, you can write 2 sets of parentheses, okay, so as a start. Okay, then how are you going to find the factors of that? The 2 linear factors of this quadratic trinomial. You're undistributing, so how are you going to do that?
X in each one.
So x in each one, Grace says, okay.
And then, and then minus 10 plus 4.
Now, so Grace says minus 10 and plus 4, okay? Okay, I'm going to take you through a thought process here, so I want you to listen carefully to what I'm about to say. Can you, everybody listen carefully? No extraneous thoughts or conversations from you, right? Okay, right now, this is 40, which is a positive number, but you look at over here, you see a negative number. So what does that tell you 40 is going to be the product of?
2 negative numbers.
2 negative numbers, okay? So you can just write in a negative at that point. And so now, you're looking for those 2 negative numbers, which when multiplied together are 40, but when added together are going to be negative 14. So what are those numbers going to be?
10 and 4.
They're going to be 10 and 4. And so is that a complete factoring?
Yeah.
Yes, it is. Now, one other technique you have available to you also is you can write out a box. And in the box, you can go ahead and put in the upper left corner, upper left cell, you can put in x squared. In the lower right box, you can put 40. And you know that's x and x. So then you can kind of experiment with different numbers. You can try, you know it's negative, so you can try negative 2 and negative 20, for instance. And here you get negative 20x and negative 2x, but then you add those together, you get negative 22x, so that's not going to work. You can try, and then you try, I don't know what else you can do, 1 and 40, 5 and 8. You could try 5 and 8 also, couldn't you? But then you would get negative 13. So the only one that's going to work out after some trial and error is going to be, as Grace says, to try this negative 4 and negative 10. So here you get negative 4x and negative 10x. Okay, so this is going to be our correct answer for number 10. Okay, the last one here is number 11. And number 11 has some more complexity to it. I kind of saved the most complex for last. But it's going to be similar in a way to number 5. And so, I mean, most of the factoring ones we're going to do are going to be pretty easy ones, like number 10 and stuff like that. But some of them are going to have some. What makes number 11 more complex? What makes number 11 more complex is this thing right here, because not only do you have to worry about the factoring that creates this negative 15, you have to worry about the factoring that creates that 4 as well. So that's the complexity. So I had in first period, did anybody work out number 11 yet? Find that? Any answer to that yet? Okay, in first period, we have a student sitting right here. I think he's sitting right here, Ethan,
That'd be old dog
who figured it out.
Ethan, oh, that sounds like
Black
something
hair
I do.
Yeah, it's a long
Black-haired kid. Dixon.
Yeah, right. He figured it out, and he knew it was this. So what I'm going to do for this is, basically what he did is he wrote it out like this, and he did just experimentation in his mind. I asked him how long did it take him to get it right. He said it took him 3 guesses, like trial and error guesses, to get it right, and he did that. But what I'm going to do is I'm going to show you the technique. I'm going to show you a technique where you can go right to the right answer on this, okay? And it's called sometimes the X method, sometimes the bottoms up method. And I don't know what I'm about to show you if you've seen it before. Have you heard those before, X method and bottoms up before?
Heard of something else?
So I'll show you what it is, and then you can tell me if it rings a bell. So what you do is you go ahead and make an X like this, a pretty big X, and then you go ahead and write this. You write A is equal to 4, B is equal to negative 17, and C is equal to negative 15. Does that A, B, and C look familiar to you? It should from yesterday. We talked the quadratic formula. We talked about A, B, and C, so we used those yesterday. Most of you are here. So what you do up here on the top of the X, we put the product of A and C. And down here in the bottom, we put what B is. So what's the product of A and C? You multiply A times C, what do you get?
60.
Negative 15 times 4 will be negative 60, okay? And down here you put what B is. B is negative 17. And so what you're looking for is 2 numbers which, when multiplied together, are negative 60, but added together are negative 17. What are those 2 numbers? And so what you do is you think of factors of 60, basically. What are your factors of 60? Well, 2 times 30, 3 times 20, 6 times 10, right? So what 2 factors will add up to negative 17 when multiplied together are negative 60?
We'll add up to 17.
Okay, I gave you some possibilities.
Something
Like 1 and 60, right, are 2 factors. 2 and 30, 4 and 15, 6 and 10. So which one of those sets is this going to be?
that adds up. Like you said.
Which set adds up? You have the numbers you have to deal with are like 1 and 60. I'm just thinking of factors of 60, right? 2 and 30, 3 and 20,
3 and 20.
6 and 10. You think it's 3 and 20?
Because you can subtract them.
Yeah, so it's going to be 3 and 20. So let's talk about that. So you just have to think a little bit. So what does it have to be? It has to be negative 20, right? So yeah, you add those up, you get that, you multiply together, you get that. So it takes a little bit of mental math to do that. So that's, and then what you do is you divide by A, and what is A? 4, and then you simplify. So you have negative 20 divided by 4, which is negative 5, and then you can't really simplify this over here. And so your answer here, you're going to have x minus 5 is going to be one of the factors here. And then you take this right here, this x, the other one, x plus 3/4, and this one right here is where you use the bottoms up. And in bottoms up, what you're taking is you're taking this 4 and you're bottoming it up here. And so what you're going to get for this is you're going to get 4x plus 3. and then 4x plus 3 goes here. Now and so what you have when you go ahead and work this out, you should see that you have negative 5 times 4x, that's negative 20x, and then 3 times x is 3x. So this is going to be your complete factoring. Now, I want to talk just briefly, what's good about this, what's bad about it. What's bad about it? Yeah, there's a lot of steps, right? There's a lot of steps. And because there are a lot of steps, it might be easier for you just to do the experimentation mentally to get this. So that's what's good about it.
Get the right answer.
It takes you directly to the right answer without guessing and checking. And so you just have to make a cost-benefit analysis. I will tell you, before I got into the math teaching business, I did these problems the way Ethan did them today, just kind of by quick trial and error, just a few methods. And so gradually what you're trying to do in your algebra and mathematics techniques is you're trying to develop your techniques that work best for you, which aren't going to be the same for everybody. So anyway, what I want you to do is to turn this in, and then we're going to start on something else. So who can pick this up for us today?
Me.
Who volunteered to pick it up?
That's me.
Well,
Ah.
have you been eating your work again there, Dan? Oh, do you? Okay. Is that the table right there?
No, it's
Okay, great, thank you. Another thing, sir, I tell you, I do appreciate your comments today. I'm going to give you extra credit on that. It's really good work. No, she had good comments.
That country?
That's right.
Well, you offer opinions. You offer opinions. What's good about it? Get involved in class. Good job.
There you go, Mr. G.
Oh.
Oh, hold on, there's two more.
31st grade.
Yeah.
Here you go, Mr. G. Oh. You hit my bad shape.
I got
The first time?
The
first time?
All right.
Oh, it is.
Say what now? When I got home, I went to the face paint.
Okay. Basically, on this set here, we're going to get some exercises in factoring out, doing some basic factoring using a greatest common factor. And they give here at the top of the sheet this example problem where you have this 4x squared minus 8x, and they factor out the 4x and multiply that by quantity x minus 8. And because in common to 4x squared and 8x are this 4, and so 4 is a common factor to each of those, and the x is common to the x squared and the x. And so what you're doing is you're doing the undistributing is what you're doing with this, okay? Okay. All right.
Done?
Let's go look at, let's look at number one. We'll do just a few of these. Most of these you're gonna probably want you to take home but we'll do a few of these. So in number one, we have 9a squared minus 18a. What's in common to both of those terms? 9, right? So we're gonna put the 9 out front. And what's in common between a squared and a? It's a. So we've unfactored that, and then what times 9a equals 9a squared? A. And then what times 9a equals negative 18a? Negative 2. And so this is our completely factored expression there, because if we redistribute, if we go use the distributive property, we're going to get back to our original. Okay? And again, just to kind of tie what we were talking about is what you would use this for is if, let's say you had the equation here, 9a squared minus 18a is equal to 0, you could use the factoring to solve this equation. Because if you have 9a times a minus 2 is equal to 0, then you would see here that a is equal to 0 and a is equal to 2. So you could use it for, and also we showed yesterday by graph, you could use this for graphing too. So we don't have very long of class left today. Do you want me to show you a couple others of these? So let's go ahead and look at 2. So 2 just has a lot of stuff in it, right?
Yeah.
A lot of stuff. And so you just kind of go through this stuff one thing at a time. And so the first thing you do typically is look at the numbers. So in between 16 and 32, what's in common between those two? 16. 16 is your common factor between both of those numbers. And now the a to the 5th and a to the 4th, what's our greatest common factor between those two things? Actually, a to the 4th. A to the 4th is common to this and common to this. Now the b's. Between b cubed and b, which is the greatest common factor between those two things? It's just b. And so now, so we found the greatest common factors. Now you draw the opening parentheses, and what times 16 is equal to 16? 1. So we don't have to put anything. And what do we multiply by a to the 4th to get a to the 5th? A. And what times b equals b cubed?
3.
No.
B squared.
B squared. And then plus, what times 16 equals 32? 2. What times a to the 4th equals a to the 4th? A to the 4th. So we're not going to put anything because this was already factored out. So we're not going to have to put anything representing a here, right? What times b equals b? Nothing, right? 1. So we'll just go ahead, we can just go like this. And then if you redistribute, to check your work, if you redistribute, if you just go like this, you should be able to see that we would get back to where we originally started. So right. With phones, if you have something that's emergency, I realize that it could be that, let me know. We can send you someplace where you can do that. Can you do that in the future? Thank you. All right. Okay, any other ones you want to look at? You want to look at 3? Yeah, so 3, you have this right here. You have x squared, x to the 4th, x cubed. So what's your greatest common factor between those here? X squared. So x squared times what equals x squared? What times x squared equals x squared? No. 1. And what times x squared equals x to the 4th? x squared. And finally, what times x squared equals x cubed? X. And for these, I want you to do one last step on this, is when you do something like this, we want to go ahead to make it look prettier and more conventional. I want you to rewrite this in standard form. So we'll put x squared plus x plus 1. Okay? So just some exercise like this to do. We can come back, and we're getting toward the end of class time, so we can come back and work on these more tomorrow. Will that be all right? All right, thank you. Appreciate your participation.